Forward to the cloud. All right.
Well, welcome everyone to the July 13th, 2021 session of uh, Zoom for TangerineSDR and HamSci technical session. My name is Dave, KV0S, and this week I've been both working on some magnetometer stuff with Dave Witten and Dave K-E-A-Q-E-P, and also I've been doing some work on the actual FPGA stuff with Kong. So we've had quite a few things going, as well as we've been having a series of storms here. So it's been a wet year in the summertime this year. So that's it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Lots of stuff going on over here. I just finished up a draft of a manuscript that's going to the Society of Amateur Radio Astronomy conference, and that's going to talk about the architecture of the personal space weather station, the TangerineSDR with a lot of the engineering details in it, and it's going to talk about how it might be able to be used for radio astronomy. And so that I'm circulating that manuscript now. So that was a big thing. I'm working on trying to get this chirp sounder debugged. UHA released some sort of an update on it because there was some sort of memory leak. And I'm trying to make sure that's working. And it's been a little bit tough, but we're still trying to get that going. And we're actually going to have Scotty visit Scranton next week. We're going to have a radio summer camp for high school students. So he's going to get to meet Kung in person and meet some high school students here who are going to be learning about radio physics and engineering for the first time, and also meet some of the research students. So we're really excited to have Scotty come visit us. So W2NAF, back to net.
Well, fine business. Next on the list, we have Dan in OD. I forgot your call sign, Dan. Go ahead.
I forgot to put it up on my, anyway, it's N4XWE, but that's beside the point. Okay, thanks, Dave, and hello, everyone. Not much to report. Somebody actually gave me a star on my GitHub page, which surprised the heck out of me because I didn't think anybody ever looked at it. So, anyway, thanks to that anonymous person, whoever it was. And I guess that's about it from here. Go ahead.
Well, fine business, and you are doing good work, Dan. So next on the list, we have Dave Witten, KD0EAG. Go ahead, Dave.
Hello. I've been working on the local users monitor for the gravitometer, or magnetometer, I'm sorry, and the real-time plot, and have that starting to work. And it also involves changes to the data collection, the run mag, and the run multi programs, so that they can feed data to this thing in real time while still building data logs. And so got that, at least the core pieces of that working, and I'm pleased about that. Otherwise, not a lot of big excitement here. It does seem to rain and rain this summer, but I guess that's okay. We're well drained over here. So anyway, that's it.
Well, Fine business, Dave. And next on the list, we have Bill in ADET. Go ahead, Bill.
Don't give me too much time to warm up, do you? Nothing to report this week. I've been pretty busy. I got a couple of health problems I got to go down to Columbus and get taken care of this week. So I'll sit and listen tonight, and we'll see you all next week.
Well, you take care. And next on the list would be David in one HAC. Go ahead, David. You're unmuted, but I'm not hearing you.
Yeah, I mean, there
There
we
you
go.
go.
Doesn't always connect for some reason. Good evening, everyone. Working on our research radios, Arctic and Antarctic, and following up on our rocket research, which got some very interesting data from that ionospheric of an ionospheric sort. One of the things that I'll mention, I don't know if I'd mentioned this before, but we realized the AM broadcast band was an illuminator, as we do down here. But as the rocket goes up through the ionosphere, the various frequencies of the AM broadcast band get absorbed progressively. It was very interesting to watch it in real time and then to go back and see that it really was in the data. Looking forward to hearing about the progress being made on these radios. So I guess I'll mention that we've had a pretty severe drought here that seems to have broken this week, partly helped by a hurricane that went by. Hurricane Elsa went up past us, but we've also been getting quite a bit of other rain. So, when it rains, it pours. When it doesn't, it doesn't. Back to net.
Well, fine business. From the looks of the weather map, you've got more coming.
Indeed so.
Next on the list, we have Ohio David. W8. Wait. You moved on me again. WE8QEP. Go ahead, David.
Okay, not too much going on here. I have been thinking about how to compare, magnetometer, like my magnetometer readings to some of the, real magnetometer stations, and whether that's cross correlation or some kind of correlation, and just beginning to understand how one even thinks about whether the signal is providing anything useful, and how to even approach that problem. So I've been thinking about that. I don't know that I've gotten anywhere, but I guess it's all about the journey. Back to Ned.
Well, fine business. And I want to mention that David found a nice piece of software. I believe at NOAA. It's called GeoMag.Pi, and it is a nice magnetometer plotter that was written for other formats, and we're looking into how to use it for some of the looks at our data. So anyway, so good job on that one. Next on the list, Hillman, KD2MCR. Go ahead, Hillman.
Yep. Good evening, everyone. Not so much to report, other than I've been busy preparing for a workshop that is mainly for magnetosphere physicists, which is called GEM workshop. At the end of this month, I'm part of the focus group leader, so I've been working on that, and also at the same time, I'm making slow but good progress for the the manual instruction for the magnetometer installation. Hopefully we can have it uploaded on the ham side. Thanks to Nathaniel, you know, I learn how to post text on ham side website, so I'm working on it. I'm making slow progress because I don't want to upload text before everything looks sort of fine still, because I still have some holes here and there. So I'm going to ask you for help. I need some clarification. I need some more information about some certain areas. So I'm going to ask you for certain specific questions later, but I'm making progress. So I'll hopefully that can be posted sooner or later. So back to that. Thank you.
Well, very good. Next on the list is James, KG4DSG. Go ahead, James.
Good evening, Dave. Hello to the group. Just sitting here listening in. Just a data point to add to the discussion last week. I had an ad thrown in my face sometime in the last 7 days that apparently the new Mac Mini now has an option for 10 gig Ethernet. So I have a feeling 10 gig is very close to being mainstream. Apple usually comes out with this stuff first, but just something to keep in the back of the mind. And with that, back to the net.
Well, fine
That's
business.
good to hear.
I actually saw a fellow that was trying to get 10 gig working on a Raspberry Pi, one of the
That won't
compute
work.
module 4s, but you know, I think you're right. I think 10 gig is not far around the corner. It may not be across the net, but at least in your ham shack, you'll have 10 gig. Sometime
It's
soon.
certainly something that if you want it, you can, it's now attainable.
Yes,
And not terribly expensive.
yes.
Yeah.
So next on the list, we have Joe, W7LUX. Go ahead, Joe.
Good morning, good evening, Dave, and all the people on the net. Been monitoring the grape receiver data and recovering from second cataract surgery. Back to you, Dave.
Did your town survive the fire threats fine?
Say again, please.
Did your town survive the fire threats fine?
Oh, yes, we had a type 1 management team come in, and what we had a 3, and they were monitoring 5 other fires all at the same time, and that was just way overloaded them. We had a type 1 come in, and they got a perimeter around it in about a week or so, and that
Okay,
that kept us safe.
very good.
Thanks.
Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been working on my test box for my active VLF antenna. I was able to finish it. I tested all the circuitry, and it works exactly as I wanted it to. Remember, this is more than just a test box for install. So this is also going to be what I'm going to use to power the VLF receiver and connect it to my VLF module when the time comes. So what I wanted to do was I wanted to, during the general discussion, talk about what I did. I have some pictures of everything. Also, I've been working on my active VLF antenna. I've been running into a problem which you guys might have seen when you were working on your magnetometer builds. The foam insulation that I put into the PVC pipe, if it's too tight, it gets stuck, and there's friction. So I was thinking about using some sort of oil inside the pipe to ease the friction. But the issue is I cut out a section of that foam, and that's where the board is going to go. And the problem is that it loses some of its rigidity, and if it gets stuck, you can't push it through all the way. And if you try to pull it out, the foam might break. So I was thinking about using a piece of twine that I could put through it at the other end, because the other end is going to be sealed with a cap. So for the instances that I have to pull out the foam insert and work on the board, or change the board, I was thinking about using that twine to actually pull it. With the board in, I haven't actually put the foam insert with the board in yet. That might add the rigidity that I need. So it's a bit tricky because everything has to fit together just right and just tight enough so it doesn't move. So the idea is that wind vibration can cause the antenna element to vibrate and make noise in the receiver, kind of like how wind vibration causes noise for seismic instruments. They might not. It's not really much of an issue with the higher frequencies, but when you're in the VLF frequencies and also the lower frequencies of ground movement, it can be an issue. So that was the reason for the foam insert, to keep everything tight and dampen any vibrations. But other than that, that's all I have to report. Back to the net.
Well, fine business, Jonathan, and keep us up to date on that. Next on the list, we have Michael, AA8K. Go ahead, Michael.
Well, thanks very much. Greetings to everyone listening. Back to you, Dave.
Fine business. And next we have Rob Robinette. I assume you're, I don't know if you're still in Hawaii or if you're back in California these days. Go ahead, Rob.
I'm back from, yes, I'm here. Can you hear me?
Your volume's a little low, but
You know, maybe I'm hold on a second. I must have selected no, it should be the right microphone. Let's see, how about if I turn up does this make a difference?
that makes it louder. Yes.
That's okay, I can turn it up. It didn't automatically adjust the levels. Is that making a difference?
Yes.
I'm very sorry. Okay. Yes, I'm back from Maui, back in Half Moon Bay, California. And I think for this group, I'm sorry, I'm not at all a regular attendee, but for this group, things of interest that I've been working on. We have been working with Bill Lyles on the Whisper station that he's preparing to get deployed up at the Eureka station. I think that's if the group is aware of that project. I've contributed a little bit, but our friend, not a member here, but Glenn Elmore, N6GN, has provided an antenna system that we're hoping will survive the weather up there. Loop on ground, it seems like the best bet for 80 degrees north. So that's one thing I've been working on. I've also been working on transmission. I'm sorry. I'm on there's a group that was organized out of Switzerland to deploy Whisper beacon transmitters across the world, and in particular to try to get them some beacons out to parts of the world that do not have Whisper beacons. So one such area, it turns out, is Maui. I mean, there's really nothing in this
in the Central Pacific is sending out whisper signals. I think there's somebody in Oahu, but not
Yes.
doing much. His signal is, I don't think he has a particularly good transmission site. So I'm actually working with the fellow who's the Tom Worthington, who's responsible for the reverse beacon network site in Maui. And with Tom's help, we may be able to deploy, in addition to that, deploy a whisper beacon that might be useful for ionospheric researchers. So that whole group is that's an enterprise I don't know if you guys are aware of, and I would think it'd be relevant to the interests of this group. So those are the two things that are of greatest relevance, I think, that I've been working on for this group. Anyway, that's back to you, Dave.
Okay, thank you. Thanks for the update. And next on the list is, let me pick up the Sabaji. Is that the correct pronunciation? Sabaji?
Shibaji.
Huh?
Shibaji. I actually went to graduate school with Shibaji. He was finishing, he just started at Virginia Tech when I was finishing up.
Okay.
And he just defended his PhD about a month or two ago. And his specialty is solar flare, radio blackouts, and Doppler effects as they affect the super Darn observations.
So welcome, and maybe you can get a microphone next time.
Yeah.
And the other, I want to recognize Veronica. Veronica, are you there?
Hello. Lately I've been working on writing some code to do a cross correlation with the data I have at the Grape at my house and the data from the Grape over by Case Western. And I've also been spending a lot of time studying for my general exam, which I'm hoping to take soon. And I've
good.
also been spending some time editing my paper for the Sarah conference.
Very good. Okay, well, next we have Scotty, WA2DFI. Go ahead, Scotty.
Okay, thanks, Dave. And let's see, this week, been just trying to finish everything up on the CAD side for the three boards, get them all coordinated, get the final changes in. I had some changes from Tom McDermott on the noise generator. And on the clock module, we made a couple of changes due to, after talking to John Ackerman, determining that we really would need a USB connection to program that to talk to the SI Lab software. So we added a vertical USB connector to the data engine. We're going to have one on the carrier board for the clock module, but I didn't have one at all for the data engine. So he said, well, that's not going to work very well. So you're going to have something like that. So we managed to find a space to stick a vertical one right behind the USB 2 connector. And we also added a header on the clock module. All this just goes to show you, no matter how full it is, there's always room for one other thing that you can add. Anyway, John wanted the UART1 brought off the clock module directly because he says that you really need that to get any kind of streaming data because UART2 is not normally enabled. So at any rate, we juggled some pins around. We ended up adding only one pin, but we moved some connectors around on the clock module. So I think this is all going to be done this week, and we're going to be ready. But we're still waiting for FPGA parts, which I'm getting less and less optimistic we're going to get. So we're looking at other alternatives for what we're going to do in the interim, but we don't have anything yet. So I'll save that for another day. So other than that, and looking forward to my trip to Scranton next week, which is going to be really awesome. Get to go to radio camp for once. I mean, I've always wanted to go to radio camp since I was 12, but now I get a chance to go finally. So I'm not sure it's exactly a camp, but since it's going to be at a university, but it'll be fun anyway. So back to you, Dave.
Well, I also wanted to mention that we approached Tapper about making another rev of the magnetometer board.
Yeah, and actually, I just tallied the votes and it passed.
Okay, I wasn't sure if it had yet or not.
Yep, everybody voted aye except one didn't vote yet, so you have to
Okay.
mention it a little bit. So that, yeah, so that's true. So we got funding to do the CAD layout for Rev-E and to build 10 prototypes. So we'll have a smaller number, but we'll have a few that Dave Witten will be able to use and to fit his 3D printed gizmos on to verify that and do other mechanical testing. Maybe Jules can help out and whatever. We'll have 10 that we can, so we'll have 5 sets basically that we can distribute. So thanks, Dave. I forgot about that.
Okay, well, next on the list, we have Tom in 5EG. Go ahead, Tom.
All right. Good evening, everyone. Let's see. Worked a little bit on reviewing some manuscripts and reviewed the schematics. Scotty, thanks for sending all those. They look real good. I appreciate that. So I think we're in good shape. Got all the attenuator values computed. I've got the software writing all of the SI Labs clock synthesizer registers using the module write command that we defined in the local host DE protocol over the provisioning channel working. So you can click a button and open the clock programming file produced by Clock Builder and click another button and it will dump out a couple of hundred module write commands formatted for the LEDE protocol or the LHDE protocol. I don't know how the FPGA is going to get all of those to the synthesizer, whether that'll be SPI or I2C or USB. We'll have to define that later, but right now it reads and parses all of that and creates the proper programming file. So that's it for this week.
Well, and we also had John jumped in there. I wanted to recognize him. And do you have any comments about your learning about CIC filters?
Not a lot of new things this week. I just been continuing working on the CIC and the FIR future design with the new parameters given by Scotty. Yeah, and that's it from me.
Very good. It's been an interesting experience for the 4 of us working together on this. Some of us trying to explain and others trying to learn and a little bit of both going both ways.
Yeah, I had very little knowledge about radio and digital filter before this, so it was a large learning curve for it.
And now Chong has done Verilog programming with other kinds of projects, so he's got some familiarity with that part.
Thank you.
Yep. So that brings us to the end of the list. Have I missed anybody else? Not hearing any. Well, then we'll make it open for general discussion.
Scotty, I think I'm gonna talk to the NSF program officer and just kind of let him know where we are with our FPGA situation and what we're thinking.
Okay.
Get their feedback as well.
By the way, I'm taking a look at the data engine. Let me share my screen here if I can do that. So I think that if you look here, this right here is where the Gig-E connector is, right?
Mm-hmm.
Well, it turns out the back of the connector is about 34 millimeters from the edge of the board.
Mm-hmm.
This is the controller chip for the Ethernet Gig-E. Well, it turns out an SFP module is narrower than the RJ45s, which is what this is, and it extends 42 millimeters in from the edge. This is a 36, so all you need is another 6 millimeters, which I think means that we could put the SF, if we wanted to convert to 10 gig, you put an SFP module right here facing out this way.
But Scotty, why do we want to go to SFP and not stick with RJ45 even for 10 gig?
No. Well, because, well,
There's a bunch of good reasons. First of all,
yeah.
Scotty, for 10 gig, you need an SFP plus, which is different than an SFP.
Right. Well, I was talking about SFP plus, so that's the size.
Okay. So Nathaniel, to answer the question, the SFP plus is just a card cage. And so it removes all the parts. You can plug into an SFP plus cage a bunch of different kind of modules. You can plug in optical modules. You can plug in an adapter module that will convert from SFP plus to RJ45. You can plug in direct attached copper modules, which eliminate all of that. The advantage of the SFP plus is that if you're not using RJ45, the power is much less and the latency is much less. If you do go to RJ45, you can plug in the adapter module. You can also get dedicated chips that do RJ45 at the expense of latency and power.
And you, you mentioned this also, so you can get 1 gig modules too to plug into SFP plus.
Yes.
So you can run 1 gig.
So really, so really by running SFP plus, we're actually much more widely compatible and flexible.
We're modular.
And if we're modular, and if we use RJ45, we're much more limited.
Yes, you'll also find the reach on RJ45 at 10 gig may be limited to between 30 meters and 55 meters or so.
Okay.
Whereas if you go to fiber, of course, even I've seen multi-mode fiber modules down in the $20 price range.
Yeah, in fact, I was actually looking at one just here. If you look, I think this one here is will run 300 meters on fiber, and this particular part here, Digi-Key for ones is $29.
Oh,
so
yeah, so the SFP gives you all of the options, and I think there's a lot of use cases where RJ45 may be troublesome.
Yeah.
Okay, that makes a lot more sense to me. I was just, I just thought RJ45 was, more common or more backward compatible. And I was just looking up that Mac Mini that they talked about earlier on the telecon, and I saw it had an RJ45 that worked at 10 gigabit. But that, now that you explained it, makes a lot more sense.
Yeah, if you find a switch, most of the 10 gig switches that have SFP plus interfaces are significantly less expensive than 10 gig E switches that have only RJ45 interfaces.
Huh. Okay.
Anyway, so the idea is we could put a cage like this on the board. And if you look at the drawing for the cage, this is it. So this is 42.3 millimeters to the edge of the board. Now it hangs off, which is fine. The module hangs off because it sticks out of the cage. But it's only 16 millimeters wide, which is amazing to me because the RJ45 is, the connector is like 19 millimeters wide. So it's narrower than an RJ45. And so if we can get this 42 millimeters distance here, then we should be able to put it in land it right here, I'm thinking. And the question is, will it fit between the edge of the board and the leaf module? So that'll be because this probably goes under the leaf module, because the leaf module, I believe, comes down right here outside of this hole. So it's going to be, the boundary is going to be somewhere right in here. So it's going to be close. So we may end up having to extend this board edge out by, a millimeter or two to give us enough room. But I think it's doable. Otherwise, the other alternative is to put it down here, but you can see there's really not enough room here. And the new FPGA, if we use a big one to with transceivers, is going to be about 3 millimeters wider, 3 to 4 millimeters wider in each direction, which means it's already crammed in as tight as we can make it. This is the memory right up here, and we probably, someone pointed out to me too when I was talking about this, is if we go to 10 gig, we probably are going to need more RAM. we're going to need more high-speed memory for packet storage, for intermediate packet storage, because are the packets bigger on 10 gig E than on regular 1 gig Ethernet? I'm not familiar. I don't know the answer. So
typically, if you want to achieve 10 gig speed, you need to go to jumbo packets, which are about 9,000 bytes. What happens is if you stay with 1,500 byte packets, you tend to throttle the connection speed down because of the number of packet operations you have to do.
okay. So more memory would likely be a good choice.
Yeah. Jumbo frames, you need to go implement jumbo frames everywhere, but doing so really does increase the throughput quite a bit.
We do have 256 megabytes of RAM, so we have quite a bit, but that has to be shared between the local processor, whatever we use, and data storage. So, and then yeah, go ahead,
Scotty. I got a question. Moving to the SFP, is that an attempt to future-proof the design? Do you even have a transceiver on the FPGA that can drive 10 gig?
not on this one.
Not on this one. So
I can't get this one, so it really makes no difference.
True.
Sorry, I have a bad attitude here because I can't get the parts to build this.
but putting in an SFP interface, if you have to either repurpose the FPGA or come up with a second generation data engine, you're more or less future proofing at least that part of the design. Is that what you're looking at?
Yeah, that's kind of it. And we would have to go to a higher powered FPGA, which means more expensive. So that doesn't obsolete the MAX10 design that we just finished. That just means we have to delay it because I can't get parts. So that it will still come out, and it will, because we have to have a low cost version. Now we can't just raise the price on everyone because of one glitch. The MAX10s are supposed to be available again someday. So I think also not everybody needs 10 gig.
Granted, and this is low cost, and it is backward compatible. You can get gig E on SFP. The question I got is that module does extend out past the side of the board. Has there been any thought about what it's extending into? I mean, casing or?
No, this edge of the board is where all the I/O is.
Okay.
There's the power connectors here, followed by the gig E port here, followed by this. This is a vertical USB 2. Then this right down here is a USB 3. So you can see this edge, and then the clock module is here, which is 3 SMAs on it. One of the SMAs is right over this USB. So we got an SMA here, which you can't see because there's no module plugged in.
Right.
This is the M.2 connector for the clock module, which goes roughly from down here up past the FPGA. And there's a notch cut out for the leaf, and then it comes over here below the USB 2. So this edge is pretty well filled up, but it occurs to me we don't need gig E, RJ45, and an SFP plus 2. So and I didn't really realize how small the SFP pluses are. So if it'll fit in here, then that's really going to be the ideal way, because we can basically just leave all the other peripherals alone. We're just going to leave them all on there. Everything's the same, except now we're going to use an FPGA with transceivers, and we're going to hook it up to the SFP plus.
And you need more RAM, right?
And more RAM. And we're like, if I want to pay, I can get more RAM in that same footprint. It's already wired for a 4x bigger RAM. We wired the extra address lines up to the no connect pins, so we could drop four times bigger RAM in there. But right now they are kind of pricey, so you don't want to do that on the low cost one.
So does that since you can fit that SFP plus in there, does that mean we get to keep the leaf board too?
Yes.
Okay.
Yes,
and does that also save on NRE?
No, not really, because the biggest part of NRE is going to be when we replace this down here.
Okay.
Because what you can't see is all these are, and if I zoom in, you could probably see them. Each one of those lines down there is a differential pair.
Yeah.
These are all the differential pairs that go to the RF modules. And since we're keeping the design of the RF modules identical and the clock module identical, all of that routing stays the same, except this FPGA changes. So now all this routing, what we're going to do is we're going to rip it up to a line along here and then see if we can pin swap in the new FPGA to connect these up. You may get away with a lot less work, but you just don't know. It just depends on the pinout, because the new FPGA, which we don't know what it is yet, will probably be a 750 pin BGA. This is a 672, or maybe as high as 1150. It depends on what I need to get the IO, because I need 500 IO or so. And it's to be determined what part I can actually buy that will actually do the job. So I got two criteria. Can I really buy it? And you might say, well, if you can't buy the MAX part, why can you buy one of these parts? Well, the short answer is these higher cost parts and higher performance parts are built on Intel's fab line, whereas the low cost ones are built on the TSMC fab line, which is contracted out by Intel. And the TSMC is where all the backlog is. So you can actually buy high-end parts from Altera Intel right now, but you can't buy low-end parts. And of course, we used a low-end part, so we're stuck. So I think it's looking like it might not be the biggest part. The biggest problem you have is not really, I mean, because everything connects to the FPGA. So when you change this, you kind of change everything. So that means the rerouting is going to have to start over again. But the placement, I think, if we can keep the placement very close, that saves us a little time in having to move things around. And like what my CAD guy says, you go up here well, this is a bad example. Let me go up to here. Okay, so you go back up to here, and you see that and if I get this right, this I believe. Yeah, this is the USB 2 chip, USB 2 connector right here. This is the USB 2 chip. This is the USB chip to the USB. Now he says I can grab this entire thing right here and move it. I can grab this entire thing right here and move it. As long as they stay in the same relation to each other, you can leave it routed. He says the memory right here, which looks pretty awful when you look at it. When you look at all these lines coming down here into the FPGA and the FPGA end, let's see. Let me get signal planes here. As long as this stays in the same relationship, like all the bypass caps and pull-ups, they stay the same, that can get moved as a unit. So the things that are, and he says also, this is the main one, the regulators here, you see these things that look modular? These are the different regulators. He says, draw a box around those and they stay the same and you can move them pretty much anywhere you want because they just connect to the planes. Now, when you start moving them any more than a few millimeters, now you got to watch out, well, what planes are underneath here, because you've got to feed the power to the individual power planes. And if the planes don't come under there, like for instance here, that's a ground plane. I'm not getting it. Okay, so you see right here, I don't know what these are, but this is probably a 5-volt plane and that's a 3-volt plane, or the other way around. You can see how there's a separation here. Well, one of the regulators that feeds that plane is right there. And one of the regulators that feeds this plane is probably here or here or here. And then you can go to additional planes. He's got these numbers. See, this is a split plane, also a power plane. So you can see one of these will be 1.2 volts, and one of them will be 1.8 volts, and all the different powers that we have. And each regulator drives one of those planes. So like, if, for instance, if this regulator here, and you can identify them by this cluster of 12 vias. This is the ground plane underneath the regulator chip that's conducting the heat away from it. So there's 4 regulators right there. So if you move this regulator way over here and it feeds that ground plane, then you have to move that ground plane over there too. But if you move that ground plane over there, then you got to be careful of what's over it, because what we spent a lot of time on this too, is you go to the layers Okay, and I unfortunately on this PDF, I can't show you 2 layers at once. But what you got to be careful of is you can't have a lot of these traces here crossing over a split in the ground planes and in the power planes, especially not ground planes, because each one of these, if they're single ended, when they send a signal out, they get a return current that flows back more or less underneath the trace in the ground plane. So if you put a split, say right here in the ground plane, and you make one of these an analog ground plane and one of the digital ground planes, say, well, the current, the return current is going to find its way back some way. And so the return current may end up flowing through part of a plane that has signals in it that you don't want to be disturbed by the return current of other signals. So you want to always produce a round trip path uninterrupted underneath every signal. Now you can't do it 100% of the time, but you can do it such that things like an I2C port that runs at 400 kilohertz doesn't matter very much. But a RF module port that runs at 125 megahertz, that matters a lot. So you got to make sure that all the critical signals that you do that for, and then the ones that aren't so critical, you can make some compromises, because there have to be compromises. You can't, unless the planes are all 100% one layer, and then you'd end up with an 18 layer board. You have to use split planes, so you can put multiple voltages on one layer. But then you just have to watch out. And ideally what happens is, if I have a split VCC plane above these traces, this is the top layer, so it would be an internal. Pick a layer like this. If I have a VCC split plane above it, I make sure I have a solid ground plane below it, because the ground planes are typically all solid, and the VCC planes are the ones that we break up. So, and also if you go, if the layer stack up is like ground, trace, VCC, the traces on this layer are closer to the ground than they are to the VCC, so the ground is more likely to carry return currents, less likely to be disrupted by splits. So this is why this board's taken so long, one of the reasons. I mean, it's just, I'm glad I'm not the one laying it out, because it's daunting. The number of, and you see all these traces in here? These are matched lengths in groups. So all of these and all of these are matched lengths. Those shorter ones are matched. And so, for instance, the A to D inputs, we have two 14-bit LVDS buses. Well, within each 14-bit LVDS buses, the length is matched to within about 2 millimeters or 1 millimeter, so that all the signals arrive at the same time. And then, but they don't have to arrive at the same time in the second group, because the second group's driven by a different set of ADCs. Well, in our case, we aren't using the second groups, but someday we will. So they should be grouped together. And then the transmit group, which is these guys, I think it's these guys down here, which we don't use either. They're all matched to the same lengths within so many millimeters. So the signals arrive within picoseconds of each other on all of the lines, which helps us do a source synchronous data transfer between the parts much easier. So there you go. More than you ever wanted to know about laying out a high-speed board.
It looks great.
But I still think if we could fit that in here, in this area right in here, that would be awesome. It would make everything so much easier, as far as not having to move everything.
Scotty, just because I like good news, I thought I'd mention that I got an EOL notice on the PCA 9615 I2C bus thing for the magnetometer.
Oh no! So
well,
do we have a replacement or anything?
Yes, there's what looks to be an indistinguishable replacement, but they're saying put your last order in now. But yeah, sometime in December. But yeah, I can't see the difference between the new chip and the old.
So
one.
it's a drop in, the same pad out, same pin.
It looks like it, as far as I can tell. And they provided the old data sheet with it, And I really don't think there's a difference. But for some reason,
Did you get that from Digi-Key, or who sent it to you?
Digi-Key sent it to me, I think.
Okay.
Uh-huh.
If you could drop me a note, I'll make sure to update ours to the new part.
Yeah, it's got a Z in it somewhere. I'll send you the notice just so
Okay.
you know. Uh-huh.
Okay, thanks.
Sure.
Good news, huh?
Yeah.
Yes. Well, my good news would be if my rep would call me up and tell me he has FPGAs for me, then I'd be much happier.
Scotty, I got another question on this SFP. You've got active electronics that's currently set up to drive the RJ45. It's on the board, on the data engine.
Right. We have an actual PHY chip.
You got a PHY chip. I don't know much about the SFPs, but what's the possibility that that actually moves on to the SFP?
Well, the SFPs are mostly just a modem. They're take a high speed 10 gigs stream and impose it on a fiber or copper or whatever it is whatever your medium is.
But that's what a PHY does, isn't it?
Right. So the PHY is essentially going to move into the FPGA the way I see it.
Well, there's in IEEE, they define what's called an MII, which is a media independent interface.
Mm-hmm.
I think that's the interface to the SFP plus cage is an MII. And then the media conversion function happens inside the plug-in module. For example, you might have fiber, or you might have direct attached copper, or you might have an RJ45. You could have any different kind of media. And so I think that the defined interface is the MII, media independent interface.
But then they're different for different interfaces. So there'd be a 10 gig MII.
That's
interface,
correct.
And that's what we would interface to with the FPGA, as opposed to a GMII, which is what we interface to now.
That's right. That's right. They're different for the different rates.
But so then essentially the PHY is being pulled into the SFP plus module because we would talk to it with this media interface rather than just a straight data line.
Which the point I was trying to make is might free up some of that real estate that's sitting right behind that port.
Yeah, I think Scotty is planning to, I think we're talking two different modules here. Are we, Scotty?
I'm not sure that the question is the logic I'm taking off would be the 10 gig, the RJ45 and the PHY for one.
Okay, so you are planning to take the PHY off.
Right.
Okay.
And then the PHY would be inside the SFP plus, and we would interface directly to the FPGA with that.
So the clearance issue is really the only issue.
With the clearance with the leaf.
Yeah.
And I mean, even I suppose we could notch the leaf out, but as soon as you do that, then you make it a standard Raspberry Pi hat not fit anymore. And I'd rather extend the board a little bit than make the standard board fit. Then I don't have to worry about it.
So Scotty, are we talking two different data engines? One that's 1 gig E with an RJ45 and a future one with an SFP plus and a 10 gig? What are we talking?
Yes, data engine Mark 1 and Mark 2. Only
Got
Mark
it.
2 is going to drive past Mark 1 because of parts issues.
Right, okay, that's a good way to put it. The schedule of the two can be decoupled from one another.
Right. And I mean, if I get the parts, if some magic happens and say in September they show up with the MAX10 with the Mark 1 parts, we'll build that because we're all ready.
Right.
So it's just that I can't, I could modify this design for 10 gig faster than I can get the part, since it's like 8 months. So,
yeah.
And if I can't, then you guys better fire me. So
well, last I heard, component shortages are forecast out to the end of this year. And that was, I think, a keynote speech by AMD.
Yeah, and I've been given a date of February of 22 for the parts.
Whoa.
No, and that's just the one part because I have all the rest of them, but that part is the laggard.
It's
So
an important part.
yeah, and I wish it had been a different part that I could maybe design out or design around or something, but when the engine isn't available for your car, you can't go very far.
Yeah, Scotty, one other consideration, when you start plugging in modules, there is an interface in the module that allows you to read and write and set the registers in the modules.
It's like an I2C.
I don't know if it's I2C. There is a particular format for it. I forget the nomenclature, but it lets you say, do we have loss of optical light on an optical interface? Do we have a direct attached copper connection? There's a set of management registers.
Yeah, it's
that
called
you then talk to.
It's called MDIO, I think, is what you're talking
Okay,
about.
yeah, that's it. MDIO.
And we have that interface to the file already, so I'm presuming it's going to just continue to the SFP plus.
Okay, yeah, there's just more pages of registers, that's all.
Yeah, I'm sure there's a ton of registers. But the last time I looked at SFP plus or 10 gig modules, they were like $500. So
they're now $20 modules, and the SFP plus to RJ45 modules are fairly inexpensive as well.
So then you could theoretically take this and plug it in an RJ45 version of the SFP plus and connect to the Raspberry Pi with RJ45s, right?
Yes, you can. The last I priced out those SFP plus to RJ45 modules, they were in about the $70-something price range.
Okay, and do they use regular like Cat6e cable then to do gig?
Yes, it does. It does. However, there's different versions. Some of the RJ45 plug-in modules only support 30 meters. Others support up to 70 or 80 meters, but there's a price difference between them.
But we could certainly do that, and as a desktop debug station, that would be an alternative. Although
right.
I don't know what a Raspberry Pi is going to do with 10 gig hose aimed at it.
Yeah, the problem with the Raspberry Pi right now is the throughput's limited to about 4 gig because it has only one PCIe lane that's driving the interface. And so you really have a significant speed limit on the Raspberry Pi.
One thing that's interesting is that the memory controller on these FPGAs, on the higher end FPGAs, is a hard memory controller, which is better for us because it takes no logic elements to do it. Secondly, they also typically contain a PCI Express hard controller, at least one of them. And one of them I saw was a Gen 3 8-lane controller. Now, I don't know what, it's a shame to just leave that sitting idle, but I can't think of a thing to do with it. So.
Right. So one of the key things on the modules at 10 gig is that you have to have an efficient way to chain buffers in software, where you have to put together all of the buffers, and the IO basically takes a pointer to a linked list and offloads all of that work from the software.
So that you get a chain of data, big hunks of data then.
Yes, and it does what's called the scatter gather function, where it takes all of those buffers in memory, links them all together, and gets the software out of the processing.
Yeah, because I can build a scatter gather DMA engine in the FPGA, but does the Pi have one?
No, it does. There's some in the kernel, but that's another performance limit.
But you could also run it with a regular, more powerful computer.
Yes, you can, but you have to be worried about performance issues.
Right.
Well, so here's a question then for that. Suppose that we were to take a 10 gig port into a 10 gig router and then come out of the 10 gig router with a whole bunch of 1 gig ports.
Yes.
So we could theoretically feed 10 Raspberry Pis off of one of these boards without even breaking a sweat, if we could route the data that way.
Right. So on the 10 gig link, you would just have packets with 10 different MAC and IP addresses, and the router would take care of it for you.
which is kind of where my insistence on multiple on both ends came from, because I could see this coming, is that you're gonna rapidly outstrip the ability of the computer to handle whatever it is you're sending it. So you're gonna need multiple computers.
Yeah, you'll want to do that at layer 2 because the switches, you can get wire throughput on the switch ports. If you instead load router software and try to do it by IP address, the throughput of that box drops dramatically.
So is that just getting a special router then?
No,
That
it's
actually
treated
depends.
as a switch.
There's a switch. Yeah.
If it's an IP LAN, you can get layer 3 switching at wire speed.
It depends on the router that you buy.
No, not a router, it's a switch. They do
Right.
layer 3 switching based on IP address, but they all have to be within the same LAN. Like 192.168,
Same
1.1.
segment then?
Yeah, same segment.
Yeah, if you look at the throughput specs for some of the boxes, like the MikroTik boxes that can run either router OS or switch OS, they have big time performance limitations when in the switch mode, and they're pretty much wire rate on all ports in the, I'm sorry, they have limitations in the router mode. They're pretty much wire speed in the switch mode.
I'm thinking more along the lines of Juniper or Cisco.
Right.
Somebody's setting this up. They're not going to be looking at consumer grade equipment.
Well, they might be. The consumer grade, you can get 10 gig routers in the several $100 price range now. And if you run switch OS on them, or the equivalent, they can perform pretty well.
Some of the ubiquities have fairly good packet throughput.
And they're not expensive.
SFP, net a few under $500. Some one,
Okay. Well, not to change the subject, but it dovetails with this. John's working on the clock module carrier board. So we'll have a way to test the clock module and debug it and program it and all that independently of the data engine. Could we build an adapter board for this 140 pin connector to hook it up to, say, some kind of off-the-shelf evaluation board that would allow you, Tom, to evaluate the RF module without having a data engine, evaluate hardware without having a data engine?
Oh gosh, let me.
Or is that going to add so much time and effort that we'd be better off focusing on DE Mark II?
Yeah, I don't see how we're going to get the data out of the RF module without an FPGA, because it's got to be double data rate interface.
No, we would use an FPGA. We'd marry it. We'd build an adapter to marry it to a Thoracic data
development board.
Yeah, something that DE board that we have has a high-speed connector on it.
Okay, I don't know anything about this board, so it's hard for me to say.
See that connector along the bottom, Dave?
Yes.
That connector is
it's three segments.
It's an SF, not an SFP. I always get this confused because Xilinx has their version and Altera has their version. But anyway, it's a lot of high-speed data lanes, and we may be able to build an adapter to convert the 140 to that connector and then use the part on that board as an interim.
It looks like it has 160 data lanes.
Yeah, it's very wide and it's very fast. It's got a lot of LVDS lines.
Okay.
If there's enough, then we might be able to do it.
Well, if the options are no way to debug the receiver module or an adapter board, I'm all for an adapter board.
Okay. And we do like what John Ackerman is doing right now. He's building a 3-board set that's going to emulate the clock module so we can do testing.
So we have already in our group 6 or 7 of these boards, right? Dan has one, I have one, you have one, Kong has one.
I think Kong has one.
Mm-hmm.
You have
one of these?
Yeah. Is that Scotty, is that board capable of running LVDS DDR?
It's got a MAX10. Oh yeah, you know, at 128, it'd be close because it doesn't use the. No, wait a second. Hold on a second. Hey, Dave, look at your board. Does it have a -6 part on it? Dave?
I'm looking.
I think it has a C6 ES on it.
Yeah, it has ES.
Yes, it will do it then.
Okay, well, that sounds encouraging.
If we can get the signals, if the signals go to that connector, we should be able to do it.
Yeah, provided the board hasn't mismatched the various lengths
Yeah.
on that FPGA board.
Okay.
So another job, Scotty.
Another job, another grant from ARDC, right?
Yeah, just think of it as job security.
Oh, okay. I'll try to keep that in mind. It's okay when it's fun stuff, but you know, when it gets down to the dragging around because you can't find parts, that's not so much fun.
Yeah.
But hey, you know, it's all part of the job that you have to do. So, and seeing it all work is going to be pretty amazing when we get this going. Seeing all the high-powered people we have working on this, it's going to be an amazing project when it starts spitting out real data.
Yep.
So with the using the dev board, what limitations would that have compared to the actual data engine?
Well, it doesn't have USB 3. It doesn't have USB 2. I don't think it has USB 2 host port. It has the same amount of memory. It won't have both RF modules. It'll have only enough for one RF module. Let's see what else. It has Gig-E on it though? It has dual Gig-E.
Yes.
Right.
Scotty, can you give me the name of this development board?
Yeah, it's called the MAX10 FPGA Development Kit. Ironically enough, that's all on Thoracic. Here, I'll put it up here on. Dave's got it, and you buy it at Digi-Key, oddly enough, and it's what, $199, right, Dave, or $189?
Yeah, it was. I think it was right at $200. Yeah. I don't know. Can you see that clearly enough?
Okay, development kit. Okay, I'm just putting that. I'm just keeping the notes here.
Okay, I'll find it here on okay, back one.
So yeah, okay, let me look at chat here. If you have a link or something, I'll put it in the notes.
I'll have a link for you in a second. Okay, let me try this.
I got mine. Yeah, I think it was Digi-Key.
Yeah, because you got yours faster than I got mine. There we go, FPGA. Okay, MAX10. 4 kits. That is a lot better than 100 and something. Okay. And that's not the one, oddly enough. And then it's not the DE10 Lite. I don't see it in here anymore, Dave.
Well, we got it not long ago for Kong. Or was that somebody else's that we just sent around?
I'm the one that ordered one for Kong.
Yeah. I know Dan
could
has one
tell
if
you-
he's not using it.
It is what I got from Digi-Key.
Yeah.
Okay, so is the number in the chat the wrong part number?
What, that Digi-Key number?
Yeah,
The
Look.
part number is 5443082-ND.
That's the right one. The reason it's not coming up is they don't have any anymore. So hold the phone here.
They have a manufacturer part number of DK-DEV-10M50-A.
okay, so you say they're not available. Are they back ordered or discontinued?
They're not available from Digi-Key. Here, let me do this.
Do you have a way to get it to Thoracic?
Yeah, so here is the board right here. It's this one right here.
Okay, and
So you can order from Thoracic, which is where I ordered mine from. It's just a lot easier to order from Digi-Key because it comes faster.
Okay, but if Digi-Key doesn't have them, it's not going to come very fast.
It's not going to come very fast. So, and in fact, that's a good question. I don't know if it says buy it now. Let's see if I can buy one now. Contact us. Great. So they may be out of them too.
Yeah.
Oh,
But
okay.
we have several. So if somebody's building templates, we can make sure the people testing have what they need.
Yeah. And see, it uses the 10M50-A package, and it has a HSMC. That's the one I was trying to remember.
Yes.
That's this connector down here. And believe me, we have the AD1 board that you have, Dave, is an HSMC adapter board for our high-speed HF. And we have a bus that runs at 122.88, but we run at CMOS.
Yeah.
So it'll actually, across the connector, it'll be much better running at LVDS. So, yeah, so that would be an alternative. We could come up with that adapter board, but that's another board. It's okay. So you know what I have to do? I actually have to build a 140 pin loop back board for the data engine, which will of course will work for either data engine because we're not changing the RF module interconnection. So I can have him build me at the same time on the same substrate an adapter board.
Well,
to this.
Yeah, should we make sure that we can get some of these development boards before we proceed?
Well, we have 4 of them. I mean, we should probably investigate that, yes.
Okay.
At least look at what the lead time is. And my guess is if the lead time is anything other than from stock, you're SOL, because you're gonna have the same problem I have.
It's February date.
Yeah, you're gonna. It just depends on if they were in process. Maybe this guy has a bigger. I'm sure this guy has a bigger pipe to Intel than I've got. Because if you look at their boards, they make a whole bunch of boards varying from the beginner boards all the way up through the Stratix boards.
Okay, I'll just take a note that we need to investigate availability before starting adapter boards.
Yeah.
Say, I need to go. Talk to you guys next week.
Yeah.
Okay, 7-3, Dave.
Yep.
I think I'm also going to need to sign.
Yeah, I think we're over again. We traditionally have gone over, so.
Yeah.
All right.
Okay. So I'll contact the guy at Thoracic and see what whether I can get any info out of him because he's always talked to me.
Hey, Scotty,
pardon me?
You might want to take a look at Mouser. I'm looking at something that maybe is it 10M50-A? Well, it says no, they're on order. I thought they had them in stock. It says 164 on order, so they may just be gone.
Is it $200? The key
199.
The key to this board is it has dual gigabit Ethernet and it has the HSMC. This is the only board that has those 2 features.
You date.
That is the same board.
But they're on order. They don't have any, right?
52 expected. Well, it looks like they got orders coming in this week. Expected. That doesn't mean they're going to show up.
Right, but it says expected in July.
Like it said
7/13
tomorrow.
and 7/14.
Yeah.
Oh, so if we're going to do this, I mean, we probably only need a couple more of them, right? Because we need one for Tom, and I already have one. Dave has one. Kong has one.
Does John Ackerman have one?
He does not. So we probably need a couple.
I have one.
Dave, you have?
McGaw.
Okay.
Before we leave, is it possible for me to show you the test box?
You want to do that, Nathaniel? I'll unshare here.
Oh, you can go ahead.
Oh, I'm already unshared.
And
okay, I'm going to share the screen here. That's what I want. Okay. Okay, this is the test box that I built. So what it's going to do, the blue binding posts, that's the VLF audio. The red and black, that's the isolated DC power from the DC to DC converter. So what I have here, audio comes in and is routed, is basically routed to a toggle switch, which can toggle between. Does everybody see my cursor?
Yeah.
Mm-hmm.
Yes.
Okay. It can toggle between the RCA jack and the headphone amplifier here. This is just an LM4881 headphone amplifier board that I bought for $10. Just some quick headphone amp that I didn't have to whip up. When the antenna is going to be installed to verify that it's working, I'm going to use this box to power it. And I can listen to the audio directly with the amp. The DC-DC converter here, there's a piece of perf board here. It's underneath, and it requires 9 to 36 volts. Even if it's 8.8 or 8.9, the output doesn't work. So that's why that I had to use two 9-volt batteries. Everything is actually pretty cramped. The power jack also has it is wired, so when the power adapter is plugged in, the battery power is that circuit is open. For many years, I've always wondered why a lot of DC power jacks have 3 terminals, and the third terminal is a shunt, actually. It's always normally closed, and then when you insert the plug, it opens up, and you use it to cut out battery power. So that's exactly what I did. So when this receiver is installed and ready to connect it to the to the VLF module, I'm going to take the audio output from this RCA jack, and it's going to be powered by the power adapter. I have a 14-volt power adapter. That'll drive everything. So that'll power this, the isolated power, and then the audio will output here, and that'll connect to the board. It's best if it's earth grounded, and these are both isolated. Let me share the other. There's the schematic I wanted to show you quick. Let's see here. Okay, so this is the audio path here. This is a gas discharge arrestor. And its striking voltage is 70 volts. So if there's any voltage spikes from local lightning, hopefully that'll discharge it and not damage everything. This resistor here, it's a 10 meg ohm bleeder resistor to bleed off any charge on the feed line. And as you can see here, the audio gets sent to the toggle switch, either the RCA jack or the headphone amplifier. For the power, it's a similar situation. I installed another gas discharge arrestor, and a 10 meg bleeder resistor, but it's on a common of the isolated output this way. So I get positive and negative 15 volts. So then that gives me a 30 volts total, and I'm bleeding any charge on the feed line through this resistor. I also put some caps here to get rid of the ripple. For the power, 2 series 9-volt batteries on a DC jack, and the ground is connected to the shunt. Let's see. So that's basically what I've planned. So it's the receiver that I'm going to use is where is that window? It always disappears on me. Crap. Where'd that window go? Huh. What in the world happened to that window? Here, let's do this. Okay. Share. So this is the here it is. So this is the board that I built. This also has a DC-to-DC converter and the audio transformer, the SP70. That's good up to 100 kilohertz response. This is a line driver for the audio, and this is the input stage here for the VLF audio. So the everything is going to be connected here, and that's going to feed to the box. For the time being, I have my Raspberry Pi box that also has a similar circuit to the test box. And what that's going to do is that's going to use the Raspberry Pi to log and process all of the data. So I was happy that the test box works well. It's just pretty tricky getting the foam core to fit right, but I'm gonna be working on that the next couple of days. And there's one last thing I wanted to show quick: the schematic of the VLF receiver. This is something that this is Paul's design here, and you can see this is the DC to DC converter. There's a Schottky diode here, just in case you have reverse polarity. This is the input stage. And this filtering right here what he's using this for is to notch out 50 hertz. I modified the filter to notch out 60 hertz and also add a little bit more gain because my antenna was bigger than the one that this was originally designed for. You can see the audio transformer here, and it's important to provide that isolation, and so this is going to capture this is going to capture VLF audio, and that's going to be sent to the Raspberry Pi. So I wanted to give an update on what I was doing. If there's anything, any questions or concerns with the circuit that I posted, or anything I've done, I'd be interested in hearing them. That's all I have.
Okay, Jonathan, have you started debug on this? Or are you to that point yet?
Yes. Well, I haven't actually tested the receiver outside yet. I've been fiddling with this foam core to get it right. I don't really have a good enough place to test it, but that was one of the main reasons for this test box was that I could verify that it works. Paul uses this receiver for there was a study going on at MIT, and he was asked to build something like this, a compact VLF active antenna with a board like this and a Raspberry Pi. So he actually built a bunch of these boards, a bunch of these antennas, and he sent them to MIT. So he actually verified the he did the verification on the design. That's why that I'm not too worried about it. I just need to verify that I built it right. But with the receiver inside, I could hear 60 hertz hum, so that's usually a pretty good sign.
Okay, very good. And you say that it communicates with the Raspberry Pi?
Yeah. So the audio will feed into a Raspberry Pi sound card and audio injector, an audio injector sound card. Oh, here it is. I can share this. This is the Raspberry Pi box. You can see here this green cable. This is going to be where the Cat5 cable or the Cat6 cable comes in from the VLF antenna. I've added this is the audio transformer, DC to DC converter. There's some components underneath a board here. This is the audio injector sound card for the Raspberry Pi. It can do capture of 96 kilohertz. On the side here is a Trimble Res SMT360. The pulse per second signal is fed into the other channel of the sound card. So you have the VLF audio going into one channel and the pulse per second going into the other channel. Pulse per second also feeds a GPIO pin on the Raspberry Pi to discipline NTPD. This is this is a console port for serial access. I wanted to make sure that that was important. So I added this just in case that the network ever went down. And this is the network port here. This plug, this is for the GPS antenna, and this is for Wi-Fi. I soldered a UFL jack to the Raspberry Pi for Wi-Fi, because where I originally had planned on installing this, there was no Ethernet access, so I had to use Wi-Fi. So this is what it's going to connect to when I get to installing this.
Well, this looks very good. Good luck on the debug. Let us know how things are going.
Definitely, thank you.
Yeah, if you get some results, you may want to put a posting on the mailing list.
Okay, definitely.
Well, I'm over schedule here, so I'm going to have to leave. We'll see you next week.
Thank you very much. I'm going to go too.
Yeah, me too.
Thank you, Jonathan.
Good job, Jonathan. I like your construction techniques.
Thanks, guys. I will
Looks
keep
great.
you updated. Thanks.
7-3, everyone.
It's good.
7-3.
73.